Hello, everyone. Welcome to the Jenkins Online Meetup. I'm Liam Newman. Today we'll be doing a bunch of 15-minute demos, 15, 20-minute short demos from a number of Jenkins contributors. If you want to ask questions, you can do so on the IRC channel on Jenkins, the Jenkins IRC channel, or on Twitter. I'd like to thank all of our speakers this morning. We'll be doing a number of interesting talks, starting with Michael Huttermann, who will show us holistic pipelines. Stephen Connolly will attempt to do the impossible and fix a bug in 20 minutes live. We'll show some unit testing for Jenkins pipelines from Ozan Gunalp, sorry. We'll do some tales of training from Damien Duportal, scaling CodeLabs with Swarm Mode and Docker Compose. And finally, I'll show you how to install Jenkins, the CloudBees Jenkins Advisor, and start making your Jenkins instances more stable. All right, let's get started. We'll start with Michael Huttermann and holistic pipelines. Michael?
Yes, hello. Thank you, Liam. So I very much like your voice. I don't know if I've mentioned it already.
Oh, thank you.
Okay. So welcome, everybody. So I'm very thrilled and happy to again contribute a little slot to this online happening. So during the next 15 minutes, I would like to discuss with you so DevOps in general and some more details around Docker images and how to create and promote those images toward production, right? Actually those material, the running snippets are in my GitHub repository. So feel free to check it out afterwards and to also maybe read a bit about more concepts and those cover tools in some books or online resources, right? So I would like to quickly show you the agenda. So we only have 15 minutes, right? So we should hurry up, and I would start with setting the stage, so to provide some background and context, and then I would like to zoom in a bit more to derive pipelines and emphasize the importance of the cycle time. And finally, that's the major part. I would like to go through a holistic end-to-end demo, so demoing round trip and focusing on Docker, right? So let's start with a quick disclaimer. So you can rewind later the tape and read those slides in more detail. But it's important to understand that although those integrated tool chains are derived from real-world success stories, maybe your individual solution looks different, right? Because you have different requirements, for example. And this 15 minutes contribution is actually largely about providing some appetizers and teasers, right? So that's the basic idea, to show some concepts and also some tools, right? So I would like to start with quickly discussing so DevOps in general, right? So maybe you have asked yourself who was the first DevOps pioneer, right? So I've written a book 5 years ago about DevOps, but there are maybe some other books, right, which have some influence on DevOps, right? So maybe it's some sort of homework for you to think about it. Who was the first DevOps author or DevOps superstar? So I would suggest Adam Smith. So he lived some centuries ago. So maybe that's the first DevOps superstar. Or maybe this guy, right? So Mr. Damien also contributed a lot of wisdoms to IT actually, and software engineering, and also to DevOps many years before the term DevOps was coined actually, right? So maybe it's also a good pointer for you. It's interesting to find a holistic metric, some numbers to measure your DevOps initiatives. So it's better to take a holistic metric, for example, the cycle time, right? A metric which can be shared across many different functions in your company. Above all, of course, development and operations. So the cycle time is a good candidate, right? Or takes the coffee supply rate, right? So that's also a good example. So the cycle time is up to your definition, but very often it is the time measured from initial Git push, for example, until this trigger change is available on production systems, and both also available to the end user, right? And so it's really crucial to have a good cycle time, and you can manage and visualize those cycle times with pipelines. So now let's continue to deriving pipelines to manage actually, and to visualize and to improve the cycle time. So this is, I think, a very neat and meaningful example of a value stream map that was provided as part of a keynote some weeks ago at Jenkins World, a great conference, by the way. And this value stream map is a map provided by Microsoft, right? So you see some stages, and you see some activities, and hopefully not so much waste time, but lead time, value adding time. And once you have such a graphic, you may find some more semantic graphics, right? To nail down those different stages, for example, build and system test and production. And you identify your stakeholders, your team members, and everybody who contributes something around those changes, right? And maybe it will become obvious that after development, those changes pile up and do not proceed to production, right? So that's the moment DevOps becomes very obvious. Also, another pointer is you should check out the theory of constraints, right? So the term bottleneck is a little bit, it has a negative touch, right? But all projects have some sort of bottlenecks. So bottlenecks are really normal. It's about how to identify them and to optimize them, right? Just to increase the cycle time. So let's summarize some key aspects from my point of view. So it's about forming pipelines to create some runnable value stream maps, actually, right? It's about a high degree of automation and to inject some quality gates. But you should always consider the pitfalls of automation, right? So the more the better is not always the best case. So that's a good trade-off to find. And it's very important to form and provide releases which are consistent, both functionally and technically, right? So you want to package binaries once and promote those binaries toward production, and all different artifact types, right? So in our case, Docker images and maybe test cases and everything which makes up the release technically and functionally, right? That's very important. So it's really a no-brainer to use Jenkins 2 and its native pipeline features once you have some concepts and you come up with some logical graphics about your pipelines and staging pipelines and quality gates. But of course, you can also go with a more agile approach, right? Just to start the Jenkins automation engine and to create those stages and to form some pipelines. It's very easy. So in my quick example, I like to cover a complete workflow. So that's a workflow. A workflow consists of different pipelines. In our case, we have 4 pipelines. So those are the colored boxes, right? Continuous build and a pipeline for dev versions. And those versions produce some binaries which are staged and promoted toward production. So we do not repackage again or something like that. It's an anti-pattern. So a domain expert or the team member cherry picks a defined version and promotes the version to be a release candidate or a GA, general availability build, and brings this defined version to production to the end user. Don't be shocked. This is something I've set up. Not only for this online happening, but this addresses a big zoo of many different concepts and also tools, right? So it becomes obvious that Jenkins on the left side is some sort of Swiss Army knife and integrates a lot of different tools which are in place already, right? So for example, some tools for testing and some dedicated tools for storing binaries. That's very important to understand. And so this graphic completely maps to the slides before, right? So we have the complete workflow. It's a comprehensive, holistic workflow containing 4 different pipelines. Our focus today is the Docker image, right? To create it, and we have a web application, Java EE, which is also of course, bundled in this Docker image together with middleware, the Tomcat, and that's it, right? So we promote this Docker image to production, and this is a natural order, right? Of course, we start with the first box and proceed along the pipelines. And although all different tools are somehow triggered and in action, the tools which are in focus right now for this demo are JFrog Artifactory. You can, of course, also use Nexus, for example. It's also a great tool. And Docker, of course, very obvious, is also used. And we store our and we make available our images in Oracle Cloud, but you can of course also just replace this node in the overall tool chain and replace it, for example, with Amazon, right? So it's very flexible. Okay, now let's close the slides and let's go to the dashboard. I think you have seen this before, right? So this is Jenkins. It's a great and very handy automation engine. And you directly see, this time I don't forget to enlarge the font size. You see the different pipelines.
Actually, Michael, if you could pop it up one larger.
Okay. So.
And back by 1. There you go.
Okay, very good, thanks. So we see some pipelines, right? So those are the pipelines we have covered before. And we would like to motivate a change. So now let's also, don't forget to increase this one. So that's actually the complex business logic of our web application. Let's introduce a change. So what about, I'm in Paris. It's a very nice city. So why not doing this and bringing this to GitHub. Okay, so we can just rely on the GitHub hook or just directly trigger our workflow. Now let's zoom in to the second pipeline, right? So this is Blue Ocean. You see the stages. We also have some parallel processing, provisioning target environments, and resetting Docker and many more, right? So it's really a comprehensive, realistic pipeline. And let's go to the underlying code. So the code is stored in GitHub and checked out and just applied and run, right? So that's the underlying code based on Groovy and the predefined DSL, right? So we have some stages, and our focus is Docker, right? So we have Docker area of interest, which tries to set up a reproducible, clean environment, just stopping some existing containers and removing some garbage, actually, right? So that's a step at the very beginning. And then afterwards, we, of course, package the WAR file and also, finally, build the Docker image, which includes the WAR file, right? So that's this snippet. You see, we rely on shell scripts. So that's one possible way to accomplish the goal. And then finally, we would like to push not only the WAR file, but also the Docker image to our binary repository manager. In our case, it's Artifactory, right? So that's very important to understand that we have a semantic umbrella, right? Which collects all different binaries which are produced and relates them to this Jenkins build. This approach is based on the Jenkins Artifactory plugin, and we can also, that's also very important, you saw it maybe on the slides, that it's very interesting to, it's not only about binaries, right? It's also about adding context information to those binaries. So in our case, we add some more information, maybe what we are doing right now, to the Docker image, right? And then we can just push this Docker image to our Artifactory. So now let's quickly go back to the dashboard, and wow, that's great. So it's green. So that's good news, right? So the version was produced. We can go back to this side. We can look at the build history and click on the click through icon for the Artifactory. Build browser, and it was not a lie what I said, right? So we see those different artifacts which were produced by exactly this build, Jenkins build. So it's the WAR file and it's the Docker image, right? And we can now operate any actions on this set of binaries. So we can promote, for example, those binaries to higher environments. Okay, now let's go back to the Jenkins dashboard. And by the way, I got a lot of questions recently about this layout. So this is not the default Jenkins layout, right? So this layout is actually based on the section view plugin. So that's just a quick note. Okay, now let's go back. And why not being brave now and cherry pick the recently created version and create a RC, right? So we are listing all different available versions, including the recent fresh version. And that's it. Wow, that was quick, right? So again, we just use some remote API, in our case, Artifactory, to promote the image, right? So that was really quick. So because it was so quick, we can directly proceed to cherry pick an RC build and create and promote an GA build, right? So also this should be very quick. And also here we use some Docker magic and tool API to promote the Docker image from JFrog Artifactory to JFrog bin tray. That's all right. So now we have the GA build, and we can go the last mile and pull this Docker image stored in bin tray, or for example in Amazon, right? And make it available and run it on our cloud system, right? So it's not only about moving around some single Docker images, right? So it's about orchestration and bringing some services together, and that's demoed here in this part, right? So we stop some containers and set up some services, right? And a complete stack actually of our services, which can contain a lot of different images and containers, right? So that's really neat. So we can start it. Also this defined version, right? We don't repackage it again, for example. And let's open it and visualize it. So you see a lot of stuff is going on.
Right.
So let's quickly go to the IDE and what I said, right? So all those snippets are, this is the underlying Groovy code for the RC build. You see that we...
So Michael, can you go back there for a second?
Back to
back to Jenkins, yeah, back to the dashboard. Oh, looks like you're waiting for input.
Yes. For your question, it waits now for your question.
That's not a question. The question is, in fact, actually, so you had a build there, and then you did you rebuild did you run the build again, or are you promoting the same binary as you go along?
That's a good question. So actually, do you ask regarding the RC build or the GA build or the Oracle Cloud promotion? In any case, it's the same answer. We just take the package and the Docker image we have created at the very beginning during the delivery pipeline. So
okay.
this image
and you're sharing the artifacts between those pipeline runs.
That's also a good question. But what I've mentioned at the beginning, very often, depending on your requirements, it's a good choice to rely on the dedicated best-of-breed tools, right? Of course, you can work and archive the binaries with Jenkins. It's often a very good solution. But at least in very huge and complex project setups, it's maybe even a better choice to store those binaries in Artifactory or Nexus, for example, right? And by using the dedicated tool API, Artifactory API in this case, right? You can just promote and copy references, right? So we do not, again, run or create any images on downstream pipelines.
So you're just pushing binaries to Artifactory, or are you like pushing Docker images to Artifactory?
Indeed. So
he's doing something slightly different.
Okay.
He initially pushes the binaries to Artifactory, and thereafter all the other jobs are just pushing metadata on top of those binaries to say, hey, this is now in this particular stage.
Ah, okay.
Both is true. So we we create the binaries as part of. I very much like this discussion. So I very much like those contributions. Our initial set of binaries is created in our pipeline for delivering dev versions. So those are our dev versions, right?
Okay.
So that's the basic set of binaries. And we do not create any new binaries later. So we reuse, and promote those binaries. So for example, we what does promote mean? So promote, for example, means to copy a reference to a different logical repository, a staging repository, for example, inside Artifactory, right? And to deploy those images to a test environment. So,
so why is it important to reuse those binaries? You were very specific about that.
It's actually a basic concept to create binaries once, depending on your requirements, of course, and to work on those binaries, right? Because usually you create those binaries very early in the delivery process, and all downstream activities are applied on those binaries, right? So just to minimize any surprises. So you test those binaries. So this pipeline actually also has some integration tests, including those binaries and containers, right?
Sure, and recreating binaries takes time, and running the tests on them. Yeah, right.
It's not just that. Okay. So it's not just that.
Is that Michael?
If you recreate the binaries, you're guaranteed that your build is perfectly reproducible, and most builds are not perfectly reproducible. Stamp somewhere, or you're resolving your things from repositories, unless you have a guarantee, an absolute lock-solid guarantee that your builds are reproducible, then you have, every time you rebuild, you have the chance of some slight difference, which might invalidate any testing results you've accumulated. So if you build the artifacts at the beginning and then accumulate all your testing results on top of those, you're guaranteed that those test results are valid.
Cool. All right.
Absolutely, that's a great summary. So for more information, I recommend those books here. So
yeah, I was just going to ask. This is a cool discussion, but we should probably move on. So those particular books that you were showing at the beginning and those presentations would be a good place to get a more complete view. We're starting to drill down into that more complete view.
Yes, of course, it's really a mashup of many very important concepts. And reusing binaries along the way is one of the most important concepts, right? So it's of course hard to bring this into a 50 minutes demo, also covering some tools, right? But yeah, what I've said at the very beginning, I'm also up for more discussions later on in the chat, or please just go to the extreme, talk to your colleagues. Or read some material, right, about basic concepts. It's very important to actually achieve those goals, right? To accelerate the cycle time and to deliver in good quality. And okay, I'm a bit in the last mile of my demo now, right? So I've recently just triggered the cloud deployment, and now it's maybe a good moment to cross the fingers and see that our cloud production system does run the new version of our Docker image, right? So that's it from my side. Thank you very much.
Yay! All right, thank you. I'll put up a little screen here in between. It's a fascinating and certainly a very deep space to be able to go into there. We'll move right along to Stephen Connolly, who will attempt to fix a bug in 20 minutes for us live. That's a very bold move.
Okay, so can you see my screen?
Yes, I can.
Am I unmuted? Yeah.
All right. Well, so you got 20 minutes. I'm starting the stopwatch right now. So.
Oh no, I have better than that. I actually have the stopwatch.
Oh, you've got it on your screen. Oh, way ahead of me.
Yes, so that's going. So I was trying to catch a bug that might actually stand a chance at fixing, and I'm aiming for one that has a 50% chance of success rate. So I couldn't really find a good one. For 20 minutes, we need something that's in a plugin. So instead, I'm going to this feature request improvement, which is build now should override the build throttle.
Oh,
and that's in the branch.
Your screen's pretty blurry for me. I don't know if you can up your resolution at all, but
Is it blurry there too?
Yeah, a little blurry.
Okay, give me a sec. I'm gonna have to stop presenting.
Okay.
Switch cameras.
There you
go. Let's go. Give me a sec while I get something.
Slight technical difficulties. We'll restart the clock.
Right. Oh no, I'm keeping the clock going.
Oh really?
I just need to get a window
difficulties
share.
included. All right.
Yeah, there's no point in cheating. Now, for IntelliJ to fire up. Is this resolution okay?
I think so. It seems to kind of shift, but let's continue.
Okay, well then I'll just continue with what I had.
Okay, cool.
So
sounds good.
All right, we'll hope it works. So this is the if I here a little. So this is here the issue. So I don't know if you hear the ticking clock.
Yeah.
So this is where, when using the branch API build throttle, a newly triggered build sits in the queue, and the only way is is to kind of modify the configuration. And the user is expecting that build now should trigger the build immediately, regardless of the throttle. This is branch API. So let's first of all look at what we've got. So do you need a larger font?
Yeah, just slightly.
Editor font. Let's go with 15.
Cool. That's great.
So there is a throttle in here, or it might be in the CloudBees folder. So there should be. This is a bit, it's always finding the actual thing that's doing it. There we go, rate limit branch property. So, get rid of this. So what we're needing to do is we want this rate level limit branch property to allow shortcutting. Ideally, what we want is we want people to be able to decide whether they want users to override. And then up here in this throttle, we need some way of how it works. There's this queue task dispatcher, and this looks at the throttle and decides whether or not things should work. Now, the hard part is to decide what to do. And my feeling is, scroll too fast, the resolution goes blurry. Is that might be something I can tweak.
Yeah, that's about what happens. So just scroll, give us a second, and the video seems to catch up.
Okay, so what we want to probably do is, if you use build now to make lots of builds, we probably don't want to modify the throttle for the other builds. So if I do 10 builds, did you hear Moira say 15 minutes left, or was that just me?
That's just you, but 15 minutes, all right.
Yeah. So what we want to do is we want to just say, okay, the can run needs to jump out and ignore if the user triggered the build. This should ideally be the cause of blockage. So that's if this one was first, that's okay. Here, we just want the cause of blockage. So now what we want to do is we want to see what the items are and if the item has a, right. So, okay. The job property we'll need private final Boolean user boost if
So if a user requests a build, they'll be able to exceed the throttle. All right.
yes, but thereafter, the throttle will still apply. So in other words, when you boost, you're going to prevent the automated build from kicking in until the throttle has been exceeded.
So let's see. A little bit of jumping around there. You're using some editor features there to automatically fill in some methods. All right.
And I've only 10 minutes left.
Oh, 10 minutes.
You'll have to jump.
What IDE is that?
IntelliJ.
Ah, okay.
It is the one. It's the one of choice I use.
Okay.
That one. And now if we wander up here, we need user boost.
I can see that actually helps you you get things done quicker there. You can automatically fill in a bunch of lines for a method.
And right. Sorry, I'm going to have to jump to get this quickly.
Go for it. You're highlighting that, and then
there we go. This is the one I want. Before I do that,
and you're threading the user boost through from one to the next. Okay. Oh, you're adding it to the constructor. Okay. Ah, right. So you're wiring through a new constructor.
yeah.
While keeping the old one. Okay. All right. Doing all the right things with the documentation, making sure we got that too.
Yeah. So that's that bit.
Only 10 minutes left.
Ah,
Only
yeah,
10 minutes.
I heard it that time.
Yes. So. That reminds me, these should be is user boost. And right, okay. Now for the bit work. Right. If property equals null, right. if property is user boost.
So if there's a user boost and the cause is then you look at the causes to see if you can find that the user started it.
User cause is also the other one.
Hmm.
I'm just using the old one just in case. It shouldn't be needed.
Sorry, which one is that?
So there's user ID cause and user cause. So.
Oh, right. Yes. Okay. So there's some deprecated older versions of these things. Okay. So if there's a user boost and it was caused by the user, you're going to tell us, you're going to output a log saying that why you're actually going ahead.
At finer, so it's not going to actually do anything much.
Okay.
If we ever go debugging to know what it is. So
sure, yeah.
Actually. And just while I'm at that, this is 44335.
So you weren't already on a branch for this? Oh, come on.
I'm on the branch.
Okay. There you are. So you're running for.
So the last bit.
What is that?
Last bit we have to do now.
Sorry, I got to ask. What's the MVN HPI run that you're running there?
Okay, so that's going to run the plugin in a local instance.
Okay.
To hopefully allow me to actually see the bits I need to modify.
Okay.
So I have modified config jelly, and also in here I have modified config jelly.
Okay.
Now I pretty much know what this is going to be. Yes. And field is going to be boost. Yes. I think I want on the checkbox title. Now user triggered builds to skip rate limit.
Okay, so this is you changing the jelly so you can get to the UI, make the UI actually show the
yes.
expose the functionality that you've added.
Yes, and then I also need to add some files. Help user boost.html. This option to permit
5 minutes left.
Oh, 5 minutes.
Triggered builds to skip the rate limit. User builds will affect the rate for all. will consume just will not be subject to well, run it there, and we're running out of time. Let's see, localhost, no, wrong port, 8080/Jenkins. So hopefully we've got enough of this instance that we can actually configure something.
All right, so you had your HPI run, and now that's run up this little sample Jenkins instance for you to test out your page.
Yeah, I happen to have it pre-configured.
Okay.
So we have now, where is the here? Is it no? Where does that periodic rate limit kick in?
Can't help you there. Ooh, going down. Can't find it.
Folder.
Yeah, maybe it's on the folder.
No. Now we may have broken something. That's the other thing. And, you know, it's 50-50 chance as to whether we succeed.
Yeah, well, you've done well so far, it looks like. So the other question I was asking.
Throttle builds.
Well, okay, there we go. Okay.
This guy does allow trigger builds to skip rate limit.
There you go.
And there's the help file. So let's allow 2 per hour. And I'm going to have build periodically star. Save. So we're not going to necessarily have enough minutes to actually see whether this works.
Right, because it's only once per minute.
So that one, it's only once per minute, and I've only 1 minute and 45 seconds left. There's the first build. All right. Now the second build should kick in like 1 minute.
All right.
That should work. And then the third build shouldn't. So if we're willing to go a couple of minutes over,
well, could you trigger a build right now, and then the next one shouldn't, right? Right. When
I trigger one now.
Right. That means there's 2.
Now that means there's 2, but
that means the next one shouldn't.
But this one's not been allowed, so there's something still not right here. Throttle expires, and it should be user submitted.
Right.
So we'll need to actually see what's going on.
1 minute left.
Oh.
And do you have the trace output there?
I don't have the trace output.
It's not quite
so
set up.
what I probably need to do is I need to actually run this with nbn debug. Anyway, run. And edit configurations. And add in a remote on port 1000. Why is this killing me? 8000. Let's debug. And let's go to rate limit branch property. And let's see what's in there. And while we're in the terminal tab, work, jobs.
Fever pitch.
Yes. So that's it.
You ran out of time. I think you get at least an extra couple minutes here. We had a bunch of random juggling at the beginning here. Let's
cat config.xml and see what that says.
Yeah.
So we've got user boost false. Things user boost. It's not actually having set the user boost. So that gives us some hint.
All right.
So if we can find out why it hasn't set that properly,
Right.
that's working. So that field is user boost. That's the user boost there.
Mm-hmm. Oh, is user boost in all places or user boost? Okay, cool. All right. User boost is the field, and then is user boost is the property.
For some reason, it's not actually picking that up. So if I look at this guy's using throttle as field throttle. We've got user boost in there. If I look throttle, he's got user boost on his data bound constructor. That's okay. So property user boost false. So I'm going to turn that off. Let's go and see what's going on in that job configuration. So I'm going to try and finish this off anyway, even if we don't get it finished. But hopefully this kind of shows what was involved in that little feature.
Right. Absolutely.
Like again, I'm not getting things to collaborate. So I think if we want to wrap up, that's fine. It's just as good from my perspective.
So you're going to keep working on
that doesn't work as doesn't.
Yeah. How about this?
Yes.
You keep working on it, and we're going to move on and to the next presentation. While you're doing that, I also want to say, we can use this. This is the kind of thing that anyone can do, right? Anyone that does coding on Java can help out with and fix bugs like this. We can get more information for developing and working with plugins at Jenkins.io, whack developer. It's a number of development docs that Daniel Beck has put together along with a number of other Jenkins contributors. And so I'll let you continue.
I'm also running a Watch Me Code series on some other things. So if people are interested in how to actually other examples, this is probably not it's probably not a bad example to look at some of the other videos I have.
Okay, cool. We'll come back around and pick those up, and if not, we'll definitely include a link to that in the description later on. All right, so now we're going to move on to
apparently it was just not saved with allowed trigger boots. So
anyways,
might actually work.
All right, well, we'll come back to you after the next one. So we'll move on to unit testing Jenkins pipelines with Ozan Gunalp.
Hello.
In the matrix.
Yeah. Do you hear me, guys?
No, we're getting lost.
So do you hear me, guys? No?
Yes. Yes.
Okay, great. So hello, everyone. I'm going to talk to you about the framework that we wrote to unit test Jenkins pipelines. But first I'll give you some context. I'm a developer at lefray.com. It's a website operating in France. We are comparing insurance products. It's pretty boring stuff. But we do pretty good on continuous delivery and delivering code every day. So before migrating to Jenkins pipelines, we already have pretty good continuous delivery. But during the last year, I guess, we migrated all of our pipelines, different jobs that we had, to Jenkins 2 and pipeline as code.
Cool.
So,
Ozan,
yeah.
Could you actually just switch to present mode so that we have the screen?
Don't you see all the screen? Yeah. See.
It's over on the right, that little down thing, the little.
Yeah.
You hit it, and then there's a.
There it goes. Yeah.
Let's see if that works. There we go. Thanks.
Yeah. So yeah, that lets us coordinate tasks, like handle errors and retry them if it fails, and also parallelize stuff, because go ahead and like parallelize jobs in bash scripts. And most importantly, that lets us externalize the configuration from our jobs and leave only what is essential on the job. And so the configuration was separated from the workflow, and the workflow was coded in pipeline as code. And also we had a separate configuration that had that configured different different variables that are for environments and so on. So we had no configuration in our shell scripts. The pipeline as code were mostly to configure the shell scripts and coordinate the tasks and parallelize the tasks. So as I was saying, we tried to migrate to Jenkins pipelines pretty early. So we down the road we bumped to some of the things that wasn't okay, and it wasn't there. The documentation wasn't there, and so. And when we were developing pipelines, we used mostly trial and error. So we use this small little functionality that is replay pipelines that lets you modify the pipeline script and retry the job. And we little by little developed our pipelines like that. So that wasn't easy, because when you made an error, even though it's a little typo, you get this, and you should go check it out. What is script 17 and line 14 and so. And pretty early we tried to refactor some code, saying that okay, that portion of pipeline we can reuse it somewhere else. So we splitted our pipelines into small bits that we can reuse into different jobs that we are creating. So in that example that right here, we have the deploy job, the integration job, and the deploy job goes ahead and does the check packaging, the flyway migration into database, and runs the Seleniums and deploys Tomcat and so on. So we hadn't been into declarative pipelines yet, but we realized that developing pipeline code was risky, and we should test them, because we didn't know when we are going to push into the code, it will go into our master branch, and maybe it will break all the pipeline. So that's why we wrote a testing framework on top of GUI that lets us unit test pipeline codes, the GUI scripts in IDE in every code project. So right now it's in the Jenkins CI organization, and it is open sourced and available in the Maven repository. So let's check it out. Let's see if we can develop some small projects and how to test the pipeline script and make a change and see how it goes.
Great.
So right here, I'll go into the presentation mode. Yeah.
Could I jump in? Can you make your text? There we go. Thank you. And what editor are you using there?
IDE, IntelliJ.
Okay.
So right here,
I have a different theme on there. All right.
Yes, it's a dark theme. Yeah. So I have a small project. It's written in Gradle. It's a GUI project, but it can be a Java project also. So here are my dependencies. Of course, GUI. I will use JUnit as the test runner, but it can be the framework that you wrote can be used with another framework. People use it with Spark, which is a well-known test runner in GUI.
Okay.
And we have the dependency on Jenkins Pipeline Unit in version 101. 1.1. So this is some boring stuff. So what I'm going to test is a small Jenkins file that does pretty much nothing. It checks out the project. It makes a Gradle wrapper build, and it archives the test results. So the Gradle build will actually build this project. So right now I have no tests, and let's go ahead and create a test file. Let's call it jtest Jenkins file. So to create a pipeline test with this framework, you just need to extend a base pipeline test. Okay. Let me get a package in it for it. Jenkins. And move it here. Okay.
Sure.
So I was saying, you extend the base pipeline test. First, you need to set up your test. So this is the setup for the JUnit runner. And we go ahead and call the setup for the base pipeline test for the framework to set up its runner. And now we
could I ask you a question? Yes. while you're doing that? So your pipeline tests are actually sitting next in the same area as your application test.
As my project, yeah.
Your test for the project as a whole that includes the pipeline tests. And,
exactly. Okay. So normally I would have like application code here or somewhere else. I can have a multi-module project, and that little Jenkins file would deploy or test or do something else with that project.
Sure.
So actually, in our code base, we have this more or less the same exact thing. We have a directory that we have all the pipeline code, including the Jenkins file, and we have a project that has all the tests that are for them, are for Jenkins files.
Great, thanks.
So let's see. Let's create a test method. Say should execute Jenkins file. So right from the bat, the framework lets to run a script, and you just name it with Jenkins file. And the run script method will load the Jenkins file script into the local GUI engine that will interpret the script and call execute it on the local machine and register all the methods that are called into that script. So the framework also lets you, because it registers all the methods, you can go ahead and print the call stack, which is all the methods that are called during your pipeline. So if you run this, you should print out all the methods that are called in Jenkins file. That is taking.
Yeah, takes a second to build. Sure.
Okay. Well, this shouldn't be it. Yeah. Oh wait. Okay. Oh. Some errors. Okay, it says no such property SCM for Jenkins file, which is kind of normal because in that Jenkins file I have the checkout SCM, and that SCM variable is injected by Jenkins, and my local machine, which has no Jenkins in it, well, actually it does, but in a Docker, doesn't know, and our test environment doesn't know what an SCM variable is. So in the framework, we let to mock these variables. Okay, I'll had it already here. I won't type it all this down, but you can go ahead and set variables into the script. And this binding here is a standard type in Groovy, which are injected into scripts.
Right. So the binding is a structure for Groovy that allows you to set the overall global.
Exactly. Yeah. Exactly. Yeah. So let's rerun the script. Well, rerun the code.
Mm-hmm.
Test. Here it is. So it says me, okay, there's a node, and inside there's a stage. It checks out the SCM that I gave it in the mock.
Can you copy that into a bigger?
I can do that.
Sorry, make that bigger. Yeah, let's look at that for a second. Yeah.
Yeah. So then it runs a sh a shell script, which is a git clean xdf, and then it goes into a second stage, which is build and test. And inside it does the Gradle build, and it calls this JUnit step with that parameter. Okay, great. But okay, normally when you test things, we do some assertions, right? But we realize that doing assertions in that kind of scenario is pretty rough. So later on, when we were developing the framework, we said, okay, maybe we can register this call stack somewhere and see at least if the Jenkins file changes, the test result, so this call stack result changes also. So we called it regression test. And I'll go ahead and change my base pipeline test to base regression test. And this lets me to, instead of calling a print call stack, calling test non-regression. So I'll rerun it and see what it does. Okay, it said saving stack into blah, blah, blah. Let's see what it is. Yeah. It's the exact same thing. Okay. So let's take this into our Jenkins. So I have this project in a Git repository in my local machine. And the Git repository is followed by a local Jenkins. And I will just commit the code here, saying, let's say, test non-regression. And I will jump into my job. My branch is called Jenkins World, and I will run it.
Oop.
So you should imagine that that project has your application code. It has the pipeline script.
I think your screen stopped sharing.
Oh, okay. Are you sure? That's strange. Are you seeing me? No?
Just a minute. I don't. Maybe it's me. I don't think
because
so.
Hangout says that you are presenting to everyone.
It says me that I'm presenting. Why? Now it should be you.
I'll unshare it and reshare it again.
That sounds good.
Okay.
Yeah.
Is it okay? No? Yeah?
1 sec.
You're screen sharing and presenting to everyone.
Okay.
Okay.
I'm not. Go ahead.
Do you see me? My screen, at least?
Well, go ahead. Go ahead.
Okay. So in my local instance, I have the test. I have just run what I wrote. So I didn't push because it's in the local machine, right?
Okay, so yeah, your screen isn't being shared right now.
That's strange. Because
yeah,
Hangout says that stop. Well, I will stop sharing it, and now share it entire screen, share, and
it seems to have decided that it does not want to do that.
okay, that is strange. What have I done to do?
What have you done?
Okay, so you are screen sharing. It tells me that I am screen sharing, but
yeah, but all I'm seeing is your
my photo.
Yeah, exactly.
Okay, that is strange. Should I do this maybe? Would that change anything? No.
No, not seeing it.
Not at all. Maybe I should just refresh my Hangouts.
Yeah, why don't you drop out for just maybe? Yeah, exactly. This might be a more general problem because I don't seem to be able to show mine either. Yeah, no, it doesn't want to show my screen either.
Okay. I just refreshed my tab. I'll share my screen. Go ahead. And I guess it is it. No? Can't you see it?
Yes, there you go.
Yeah.
Excellent.
Okay, great. I just wrote some tests into my Jenkins file.
Excellent.
I pushed it into the Jenkins, and I see that the execution went well. I see the test results. The Jenkins file test is okay. So let's make some changes into my pipeline. Where am I? Yeah. My Jenkins file. What I'm going to do is a simple step. I'll add a stage that will write a manifest file. Manifest. And the manifest file will contain the git SHA-1 of the commit.
Okay.
So let's first
So I'm just going to ask you while you're doing this. This is a scripted pipeline here.
This is scripted pipeline here. So the framework also is able to test the declarative pipelines also.
That was great.
This example was scripted pipelines.
That's great.
Which makes a bit more sense because, well, if you're in scripted pipelines, you are doing more stuff into configuration, and your pipeline is more complicated, right? So that makes more sense to test it more. If you have only a declarative pipeline, maybe you don't have lots of configuration into it, and there's nothing to test.
True, as long as you don't get into shared libraries, right?
Yes, that's another thing. That's another topic.
Okay, yeah,
we will come to that. Yeah.
Yeah.
Not in the demo, but we will discuss.
Okay.
So manifest.txt. Let's say revision. Get a revision from by calling in its shell. Return out because I'm interested in that. And the script, I hope I'm writing it all good. Git rev parse, and I want the head. So that revision, I write it into a file. Write file. The text will be my revision, and the file will be my manifest file. Okay, so I'll go and archive this file. Archive file manifest. Maybe it doesn't take the file. I'm not sure. Let's see. We will see. So let's rerun our test and see what it says. Okay.
So you're able to just run this.
In my IDE, yeah.
Yeah, from your IDE, just like any other test.
Yeah. Okay. Oh, it says okay.
So the first thing it does,
it loads up the script. It passes to here, okay. To here, great. And it stops at write file. It says that no signature of method.
okay. So there isn't a write file.
Yeah, it is understandable because we into the testing framework we defined some of the build steps that are already in Jenkins, but we didn't define all of the steps. So that's for the user to define which are the steps that you are using, and to mock them in a sense. So to interface with the framework, you have a helper variable, a field that you can go ahead and register allowed method. So the register allowed method, which is a write file, and its signature is, what's its signature? Map. Map
Okay.
Groovy. And I'm just not interested in how it is marked. I just want to allow it. So rerun our tests. Notice that it's all on this setup method here.
Mm-hmm.
So you have multiple tests here. It will go all the way. So it says, oh, same for the archive. So I'll just duplicate the line, right here, archive, and it will take a string. Again. Okay, great. So it says it saved the stack into the Jenkins file, and we can go ahead and see what it changed in the Jenkins file. Before it was that, and now the test framework recognized that I added a stage, which called the sh, a write file and archive. But notice that the write file takes the text as null, because we hadn't said anything that sh returns from the rev parse head method, the shell script. We can do better than that. We can just mock the sh method. I'm not actually going to write it. Let's see. I have it here. Yeah.
So these are helpers that you have already configured to make that.
Yeah. Because I have only 15 minutes.
Yeah.
So what it says is that when you see an sh having a map signature into parameters, I can like that. Go ahead and call this block of code, this closure in Groovy, which takes arguments, and you can go ahead and pick from the arguments if it's script, which is equal to that. I'll go ahead and return this. If not, I know that you are doing something that this test doesn't know, so throw an illegal argument exception.
This is pretty standard mocking kind of behavior when you wanted to do this kind of testing. This is just like any other. If you had a system like this, you'd be mocking these components and having them return values that you knew what they were and do checks like that. Yeah.
Exactly. Yeah. So let's rerun it. Okay. And this should tell me in my diff.
There's those.
Yeah.
And you get the value you were expecting.
I get the value that is passed. So okay. I should go ahead. Let's see if I can commit this and that, my test, but not the Jenkins file txt, the call stack that will do the test of non-regression. I write the commit message, write manifest, and notice that I'm only committing the Jenkins file, the test Jenkins file, but not the txt, the call stack. Let's rerun this job. How many minutes do I have?
I'd say about, well, we're running a little slow for everyone, so I'd say another 5 minutes.
Okay, great. Should go faster. Go. Let's go into Blue Ocean. So this is actually testing the Jenkins file again. And I'm expecting a fail, given that I didn't commit the Jenkins file call stack. Okay. This one's pretty. It is pretty slow. Let's go ahead and
so while you're
yeah.
So while you're running there, so does that actually should that actually fail?
It should actually fail. Yeah, there it goes.
There we go.
The test should fail, saying that. Okay, so the thing actually doesn't really says that. You should see it somewhere else, saying that, okay, we are basically having an assertion to text, saying that this bit of text isn't really the same thing that I was expecting in the Jenkins file. So I can go ahead and make some refactoring into my Jenkins file.
Okay.
I'm thinking that this bit of code can be reused somewhere else. And I will refactor a method saying that wave parse. Okay. So, and I will go ahead and create another script file inside its source main Jenkins. And call it utils.jenkins. And take this bit of method that I extracted and put it there. For that, another Jenkins script can load it and call this rev parse method.
So this is sort of like what we do with shared libraries, but a little bit
exactly,
local to this.
Local to this project, yeah. So for me to call this method, I need to return the script object. But then I can go ahead, once I load check out the project, I can go ahead and, well, let's define it. Utils here, and once the checkout is done, I will load this with from source main Jenkins utils.jenkins. And in here, instead of calling rev parse, I will call utils.rev parse. So let's jump into my test and rerun it.
Right. So the load method loads that script up into the into your Jenkins file, into a variable there.
Okay. Yeah, that's not good. Source main. Oh, there it goes. Okay, maybe.
Oh, just slightly different.
Yeah.
There we go.
Delete this thing. Yeah. Rerun it.
I notice you're using load. Is that the only way to load those things, or is it the right way?
So in scripted pipelines, you can load different files into your main script.
Mm-hmm.
So this is actually mocked by the testing framework,
mm-hmm.
so that it can go ahead and find this file and load it again into the same Groovy execution, so that it can call the method.
Right. Okay.
So let's see our Jenkins file test. Yeah, it says I have loaded utils.jenkins. I run it because that's the way how you run the script. And then when I was doing the wave parse, it goes through my utils and it calls the utils.sh, which is pretty cool. But I can go ahead and put a break point here and debug the script
inside your IDE. Nice.
Inside my IDE, yeah.
Because you're running that script as Groovy, and so now you can go and debug it.
Exactly.
Nice.
Yeah. So it has stopped here. We can go ahead and see what it does in the framework. It's basically search for the method. Okay, it tries to call it right now. And here we are in the main Jenkins file, and you can go ahead and see what it has.
So now we are running a little low on time.
Yeah.
So
so I'll just wrap it up.
Yeah, that'd be great.
So that was it for the demo. And what else you can do with the framework? Oh, yeah. One thing that comes up often so the project is on GitHub. It's now in the Jenkins CI organization. It's open source. You can check it out. And
thank you very much for that.
Yeah, and it's also available in the Maven repository. And so people ask a lot how it is used and in which cases that you should be using it. So if you're developing a plugin, you should use a Jenkins rule that is already proposed by Jenkins framework. So it is a JUnit rule that you can, when you're using JUnit, you can wrap up it spins up a Jenkins instance and installs your plugin, and you can test pretty much high fidelity execution of your plugin in a Jenkins instance. But if you're developing a Jenkins pipeline for your organization, you can use the pipeline unit framework. If you're developing a global shared library, which lots of people do, you can use the pipeline unit also. And again, for declarative pipelines, there's support, but it's not, well, again, if you are doing declarative pipelines, maybe there's nothing to test. But it is supported by the framework. So so using this testing framework in our organization lets us to have lots of different people in our organization to contribute to the DevOps and the improvement of the pipeline. So we are thinking that changed a lot in our organization. So testing pipeline code is good, and you should do it also.
Excellent.
that's all.
And here's where people can learn more about this, right?
Yeah, so actually the GitHub link is here. So, well, Lefray link should redirect to this link also.
There it is, yeah.
Yeah.
Okay.
And there actually, well, right now there are lots of questions, and in the couple of coming days I will respond to them, and I guess in the couple of weeks there will be some evolutions in the testing framework.
Great. Yeah, so this is under active development. I've seen you guys. You just moved into Jenkins CI, and
exactly, yeah.
So there's a lot of things going on, and it's being improved by quite a bit. So this is really cool stuff, though. It means you can do all you can test your pipelines, test your shared libraries. That's really cool.
Mm-hmm.
Thank you very much.
Yeah, thank you.
And let's come back around to Stephen for just a second.
Yeah. So I managed to find what was up. We've got a pull request now, and the pull request includes extra unit tests and all that jazz. Fully functional. Yep. I just had between keyboard and chair trying to actually test it live.
Of course, but you know, saving things always helps. And now here's the code for that. I've got the PR. We'll take a look at that after the presentation.
Yes.
All right. Thank you very much, Stephen.
Okay, I've got to go.
Yeah.
Have fun with the rest of the call.
Thank you very much.
Bye.
All right. So moving on to Damien Duportal. We're going to do some tales of training.
Yep. Okay. Is the sound good?
Yeah, I can hear you.
Is the screen visible?
Yes, it is.
So let's go.
It's good.
So, welcome. It's second run of that talk. So, excuse me for the slide. I kept the same. So, let's go. That talk. So, we're gonna speak about strange story, and mainly about drinking champagne. That talk will be mainly about speaking about what is a CodeLab and some example. So this implies virtual machine workload, container workload, and container orchestration. That talk is absolutely not a try on a tool to make it better or a war between tools. So don't expect me to say I prefer one or the other tools. It's just an experimentation. And I won't show any code. You have a link, you can click it. It's available on GitHub if you want to play with that. It's no guarantee. It's just for our own usage.
So you prefer champagne to whatever tool it is. Champagne's better.
Exactly, better than dog food, basically. Yeah. So the main idea of drinking own champagne is, as someone teaching other people using classes, I also learn by trying things because this is a natural and human process. So 2 rules based on that. The first one is you never waste time when you experiment. Even if you throw everything you have produced to a bin, you still learn something. Secondly, always focus on build something that works and then iterate to make it optimized. That's very important, or you're gonna distribute your mind on too many tasks that more than you can handle. So this is the story of the tales of scaling some CodeLabs. So first of all, trainer speaking, we need to define what is a CodeLab. In that presentation, the word CodeLab is a synonym of what you should call a workshop or hands-on lab. So it's a part of training, so part of a learning experience. It's a practical exercise. It means that after seeing a document that explains a concept in an abstract way, this is the step where you try by yourself to understand exactly that abstract concept. This is a practical exercise. The CodeLab technically is an isolated environment dedicated to only one user. So that means that if you run, I don't know, a class about Nginx, the web server, you will have one web server per attendee of your class, and not one web server shared by everyone. This is a very important concept. So I used to say that a CodeLab is production. So the idea is to say, when you run a class, it is your production. And the pattern of challenges that you will have on that infrastructure met the same as you could have in a real life production environment. Mainly, the network will fail. If you are on a conference, the Wi-Fi will cut at any moment. Or worse, it will be completely slow. So you will spend and waste time, and so you need some music or some jokes to pass the time. And also, be sure that by running CodeLabs, you will face your worst nightmare about diversity of configuration, from someone with Windows XP trying to run Docker on that OS, to someone with a homemade OpenBSD with a Dvorak keyboard and absolutely no GUI. You will have everything you could dream or have nightmare about.
And those users will also expect you to give you training based on their configuration, right?
Exactly. But I put that assumption in the user error because when you run a practical session, your mind is not. It's more difficult to be empathetic against the trainer or the presenter than in normal life because you are in a learning process. So mainly the effort required by your brain to learn is simply disabling other cognitive function. So you are in user error mode. So even if you are Linus Torvald himself, when you are learning, you are going back to school and you lost all your reflexes. But this is totally normal. This is the learning process. This is how the brain is wired and how it works. So the user error is mainly how your user is gonna use your environment is absolutely not what you thought at the first time when you built it. So it's like in production when you build an application. Finally, the fourth challenge is time box session. This means that you will face some load peak on your infrastructure because all the attendees will do the same operation at the same time. It's like having your web application on a daily article, so everyone goes at the same time on this. So in our case, the tales I'm telling here is about the Jenkins training, obviously. So here is the content of the mission in order to give you an idea. In that CodeLab, so in that isolated environment, we have to run a Jenkins master and the build agents, obviously. So this is based on JVMs. We store the code locally, so using Git, which is a Git server written in Go, because you have people that don't want to create a GitHub account. You have people that just don't understand it or might not have access or might not have the right or whatever reason. So everything local. We have a web command line because I want everyone to have the same experience. And if we start to ask people to just run a single bash command line, you already failed because you won't have the same thing between Cygwin and Git bash and macOS old bash version and different Linux distribution. So we provide a command line on the web because the web is one of the best platforms ever. So to provide the same user experience, we have a web command line. Same for the web ID. Don't want to start a war, but whatever solution we have, half of the people won't know your solution. If you choose Eclipse, you will have NetBeans user or whatever. So we provide the tools also inside the web browser. We have to store our artifacts and our Docker images because we do Docker on that training. So when we started that training from scratch, the first 3 challenges were, first, we need to define this service list. So to define that and to put it in code, we wanted to use Docker Compose because with a single YAML file, you can have a very clear view on which service is defined. You don't have to search across a lot of different files or locations. The second challenge was the portability. the thing is that sometimes we run using VirtualBox on local machines. Sometimes we run on a cloud, but this cloud can change based on who is going to give us credits. So are you going to run on AWS EC2, on Azure, on DigitalOcean, on OVH? So we choose to use Docker to have a blueprint. As soon as we have a Docker engine, then we are able to run our isolated stack and duplicate that one. So here's the first implementation. So basically, we have a trainer, and the trainer uses Terraform, which is a command line tool to deploy infrastructure as code. So we have a local Git repository that defines the infrastructure, the VMs, and it deploys with a simple command lines. This goes through a SSH machine. It's a Boone server for security, so no direct access to the machines. And this will deploy using your remote cloud a set of VMs. So if you have 20 attendees, you have 20 VMs. Each VM start and register itself on configuration database, which is console. And finally, we have reverse proxies that once each VM has registered and started clearly, does ill check and then update the reverse proxy. So each student can access its own instance. Remember, we said it was isolated. After running a bunch of those kind of trainings, especially in context of classes, 4 takeaways. The first one, it works. Whatever criticizing we can do on that architecture, it works. So this is the first step and very good step. Second thing, it was quite easy to begin with and to operate for a few people that are technical enough. But at least it was a start, and this was the goal we wanted to meet at that moment.
So, so that means that, like, does the presenter have to be technical, or did you do a bunch of sort of work in there to make it easy for them?
You know how this should be. Basically, the presenter have to be technical enough, because it will face some bugs or non-wanted behavior at runtime, so running the training.
Sure.
And the trainer was responsible to deploy its own machines generally.
Right. Okay.
We can automate that process. This is one of the improvements that we could have, right? Mm-hmm. So the first problem we hit was the cost. Yeah, one person for one VM, it's too much. We are in 2017, and there are better way of doing that. So one of the improvement that can be done is the cost. The second one is the time to play. Building a new machine takes an order of magnitude of minutes. So when you are developing your training and prepare your lab, let's say you want to upgrade a plugin on your Jenkins embedded instance or pre-install a package to let the user play with. Between the moment where you have the idea and say, okay, I need to change that text file to change the configuration, until the moment you have a VM which is in your remote cloud and ready to play, you have to wait minutes or worse. So this was one of the main challenges.
Because VMs take time to spin up. Yeah.
Exactly. I will say no, because the configuration and the infrastructure we use takes time.
Ah, okay.
Because VM can be quick.
Okay, fair.
Depends
fair.
on how you use them. But yeah, let's say VM for sake of simplicity. So that pattern of challenge is well known since some years now. So that's why this helped us to draw the road to a native orchestration. So we want to put more people per virtual machine because the cost unit on a lot of clouds is changing, and it's not always true. But basically, in our case, the basic unit cost is the virtual machine. So we want to put more people per virtual machine to optimize the costs. The second thing is that when you start to use native orchestration, so we mean native container native orchestration, so using something like Mesos, Rancher, Docker Swarm Mode, Kubernetes, or whatever orchestrator we can have, Nomad. All those share the same property, which is they start container very efficiently. They orchestrate correctly what you want to do, your workload on the cluster. So I don't know if you had the opportunity to test, but I recommend you, if you want to play quickly with Docker or learn Docker, to use Play with Docker. This comes from the community, and this is a free online Docker as a service. You go to a page, you check that you are not a bot, and you click on New Instance, and in 1 or 2 seconds you have an instance. So I would say 2 seconds per instance. You start 5 instances, then you type the command, and you have a Docker Swarm cluster free for the 4 next hours. We talk about seconds to start instances. So that speed, that smell of speed is very interesting, especially for our use cases. And so the time to play is also addressable by untying infrastructure from services. We don't want the trainer to manage infrastructure. So here is how we tried 1 or 2 classes. So this is our current states, moving to native orchestration. First thing is the infrastructure administrator. So the person responsible for starting VM, generally the person who pays. So we still deploy with Terraform for a lot of reasons that I don't want to explain now. If you want to discuss that question after. And that person is only responsible to start a cluster, an orchestration cluster. In our case, it's a Swarm mod, so the latest version of Swarm embedded on each Docker engine installation. So you have 2 kinds of machines. You have the managers that are the brain of the cluster, and the workers that handle the container load. So you only have to do this. You could do this with Kubernetes or Mesos. We just choose Swarm almost randomly. The second thing is that you have the trainer, and your trainer is here to provide services. So the trainer have access to the Docker Swarm primitives and can schedule services and classes. Based on that, the trainer only need an SSH access to the bastion and don't need any key or any credit card to access any clouds anywhere. Then benefits. Your user can directly access your support services running on the brain of the cluster, and you don't have to care. So for the end user, nothing changes, which is good because it's the goal. One of the positive side effects we had while trying this native orchestration is that there is so much things on the Docker ecosystem that a lot of things that we were doing ourselves, we don't have to anymore. We just have to delete the worst, all those code or configuration. We don't have to maintain this. And this is some kind of IT maturity. The less code you have to maintain, the better it will be for you. So by trying that native orchestration pattern for the infrastructure, in the case of a Jenkins training, we still had 3 problems, but I would say nice problem to have, or rich problem, or first world problems. We had the scaling pattern, the monitoring and metrics of the infrastructure, and the resource management. So I just want to check on those. So first, the scaling pattern. When we talk about scaling horizontally a service, you have, let's say, reverse proxy and a middleware and the database on a basic and stereotyped application. You just want to have n times the same application. But in our case, what we want is n times the same stack. So I just want to duplicate my stack. So the normal primitives used for scaling in Docker were absolutely not useful, because we don't want to scale the Jenkins or the WebID or the DevBox service. We don't want to scale horizontally one of the services. We just want to duplicate. So this was a bit of challenge in the sense that we had to script that. So I recently started to learn Kubernetes, and Kubernetes have the concept of pods that will help to implement that. So this might be a 3rd iteration in the future.
Okay. FYI, Damien, we've got 5 minutes left.
No problem. I got 3 slides left.
Perfect.
Second challenge is monitoring metrics. So in fact, it's a false challenge. I should have done that as step 1. I did not add any way of measuring and iterating. My feedback loop was not closed at the first iteration. So I it's not a challenge caused by the first improvement going to native orchestration. The good thing in that is that there is also so much things in the Docker and container ecosystem that we just had to start a few containers as an admin and not as a trainer. And we had a lot of metrics. So starting Elasticsearch to store data, Grafana to see the metrics, and we were okay. Why did we need monitoring metrics? Because when the one VM does not work or one stack, you just have to restart it, yeah? Especially if it's a matter of seconds. It's because of the resource management. Running pipeline with Jenkins was the most complicated part to address, because we had to know how many amount of memory or CPU are used during a given training. So we had to automate the testing of the training and measure that. Because even if you give some XMX to Jenkins, the pipeline is executed as Groovy and might use more memory than you can exactly have. So you need to know what happens, or if Jenkins asks to use too much memory, then your system will just kill the container. So the good thing is that it's quick to start containers, so the restart of Jenkins was quite transparent most of the time when we faced that. But having monitoring and metric helped us to shape that and to know how many memory are we going to use to help compressing people on VMs. So we had a profile on and a shape management of resources. So takeaways, it still works, which is good. When you change something, you are happy if it works. That's the base of TDD. It's easier to begin. We don't need technical trainer anymore. They just have to file a text file, and that's okay. The cost, four times less, because we had 4 people per VM instead of 1. The big improvement is the time to play, order of magnitude of seconds to start one environment for one instead of 10 minutes. And code maturity, less tool to maintain. That's all.
Excellent. So yeah, you and I have been I've been working with Damien here, actually writing some of the helping to write some new training, and I have to say it's really a pleasure to work in from the writing and the use side, both sides. It's easy to create the training, and then also the being able to just spin up another CodeLab whenever you need it is fantastic to be able to test those things out, and then also to be able to see it work. We use this at Jenkins World actually to do some a number of things, and it worked like flawlessly. So,
thank you very much.
Thank you. All right, and now I'm up, and I'll be. I'm Liam Newman, and I'll be showing you about the CloudBees Jenkins Advisor. Really quick here. It's I just want to say how easy it is to get started with this thing, with the advisor. It helps analyze your system and make it more stable, gives you access to a bunch of the expertise and a knowledge base around what's stability issues, and sort of get analysis of your system before problems actually crop up. So I'm going to just use my local Jenkins here as the example, and I'll show you how to install this thing. It works in 2 pieces. It's both a plugin. I don't need to update that right now. Okay, and there we go. So I'm just going to go into my manage plugins, go and search for advisor. Go. Number of security ones, okay. And here's the CloudBees Jenkins Advisor plugin. I'm going to download now and install it after restart. Oh, I had already updated the Jira. Okay, there we go. Jenkins has to restart to be able to run this. Takes a few seconds. Yes. I need to add another couple CPUs to this, I think. Come on. There we go. All right. And I'm using password manager, of course. All right. So now I've installed the plugin. The CloudBees Jenkins Advisor plugin has a plugin, and then there's a service side of this. So now I need to set up that plugin to connect to the service. And all right, so now I'm going to enter my email here, my account for I'm going to. So to connect to the service, I'll need to have an account with the with CloudBees, and I can go and create one here. I could sign up with GitHub or with Google, but I actually already have an account. So, okay, so I could create an account, but I already have one set up. All right, it'll just take me a minute to get to it, though. If I can type today, that would be great. And go. There's my account. So what I've done here is gotten my password for my CloudBees account, pasted it in here, tested the connection, so I know that it'll work. The plugin lets me do lets me control what gets uploaded to the service for analysis. I'm going to use the defaults in this case. You can control which things you want. These are of course anonymized as well, but I'll go ahead and connect. And now what's going to happen is that I will get an email right off the bat that says, thank you for registering, and that I'll get another email report in the next 24 hours once the plugin actually collects the information and sends it to the service and then gets back information. I've, of course, already done this before, so I'm just going to show you, just pretend that 24 hours has passed. And I will, what I got when I did this before was an email from the advisor service with an alert about, tells me which server it was run on, what the issue was, the severity of it, and gives me a link to a page that tells me what it's about. So in this case, it's CSRF, which stands for cross-site request forgery, which is a kind of attack that people can do. And it tells me that I need to go into Manage Jenkins and set up security to prevent this. That should be easy enough to do. It's one easy example to show how this works. So let me go over to my Jenkins again and Manage Jenkins, it said, and then configure global security. And down here, there it is, prevent cross-site request forgery. And I'll use the default Chrome issuer, sure. I don't have a proxy in this case, but there's help here that tells me more about that if I needed to worry about it. And that's just as easy as it can be to start fixing these issues. Now, the report actually has some other another thing. I was running this inside of a VM. Those are the only two to start with. I'll go back and fix that later, but that's how easy it is to get started. And that's it for our presentations today. I'd like to thank all of our speakers again for the great presentations. I was really impressed to see all of the testing and analysis. Stephen actually was able to fix that bug, just took some slightly longer than 20 minutes. Once again, if you have other questions or if you want to continue chatting with our speakers. They're often on the IRC channel at Jenkins on IRC, also on the Jenkins CI-users group. And thanks again for joining us.